Hello, thank you for watching this video. So in this video, we're doing question 3 of May, June 2021, question paper mathematics paper 2. And the topic is the analytical geometry, as you can see over here. So let's go. They are saying in the diagram, S, L, and Q are vertices of triangle SLQ, having LQ perpendicular to SQ. SL and SQ are produced to R and M respectively, such that RM is parallel to LQ. SM produced cuts the x-axis at N, QM is equal to MN, T and P are the y-intercepts of RM and LQ respectively. So in this diagram, they are saying S, L, and Q are vertices of this triangle SLQ over here, right? They went on to say that LQ is perpendicular to SQ over here. So this line SQ is perpendicular to SQ, so that angle over there is 90 degrees, right? They went on to say that your SL is extended to R and your SQ is extended to M, such that when you join those 2 points of extensions, that side RM is parallel to LQ. That's what they're saying. No problem. So they're saying now, this line SM over here cuts the x-axis at point N. So the line SM cuts the x-axis at point N, and they're saying that this length MN is equal to this length QM. This length MN is equal to this length QM over here. They went on to say that T and P are the y-intercepts of RM and LQ respectively. So T and P are the y-intercept of RM and LQ, as you can see in the diagram. So 3.1, they are saying calculate the coordinates of M. So they want you to calculate the coordinates of M. What is M? M is this point over here, and this point M is halfway between Q and N. So M is the midpoint of M and Q. So the point M is the midpoint of these 2 points M and Q, because you were told that this length over here is equal to that length over there. So it is halfway between Q and M. So we don't have the coordinates of M. So I mentioned we have X coordinate for M and the Y coordinate for M. This is how they more or less look like, right? No problem. So we're doing 3.1. 3.1. So we have MN, which has coordinates 8 and 0. We have M, which have unknown coordinates, XM and the Y coordinate of M. And then we have point Q. Point Q have coordinates 4 and minus 8, right? So we want these coordinates, which is the coordinates of the midpoint. And you know the midpoint formula, which means your x coordinate of M will be equal to the x coordinate of N plus the x coordinate of Q all over 2. And the y coordinate of point M is equal to y coordinate of N plus y coordinate of Q all over 2, right? So one x coordinate of M, which is equal to 8 plus 4 all over 2, and the y coordinate of M is equal to 0 plus minus 8 all over 2, right? So which is going to be 0 plus negative 8 all over 2. So your x coordinate of M is equal to the answer to this, so it's going to be 6, and the y coordinate of M is equal to the answer to that, which is minus 4, which is the coordinates for M should be 6 and minus 4. These are the coordinates for point M. So we have those coordinates for point M to be 6 and minus 4. That's where we are. So now we're going to do 3.2. At 3.2, they're saying calculate the gradient of NS. So they want us to calculate the gradient of this line NS, right? So easy stuff. So we're doing 3.2. They want the gradient of NS. You know the gradient formula. We have point N with coordinates 8 and 0, and point S with coordinates what? The coordinates of S is 0 and minus 16. So the gradient of NS is going to be y coordinate of N minus y coordinate of S all over x coordinate of N minus x coordinate of S. What is the y coordinate of N? The y coordinate of N is 0 minus y coordinate of s, which is minus 16, all over x coordinate of n is 8 minus 0. Therefore, the gradient of ns is equal to 16 over 8, which is 2. So we get that the gradient of ns is equal to 2, which is the gradient of this line is equal to 2. So let's add that. So the gradient of this line is equal to 2. That's what they wanted us to find, and we found it to be 2. Now we move to 3.3. At 3.3, they are saying show that the equation of the line LQ is y is equal to minus half of x minus 6. So they are saying we must show at 3.3. They are saying we must show the line LQ, the equation of the line LQ is what? Is y is equal to minus half of x minus 6. No problem. So, how do we go about this? So, the first thing that we will need to find to find the equation of LQ, or to show this equation of LQ, we need the gradient of this line LQ, right? No problem. So, what we know, or what we were told, actually, what we know is the gradient of SQ, the gradient of SQ is equal to the gradient, which is the gradient of this part SQ is equal to the gradient of NS, right? It's equal to this gradient of NS, which is 2. So I'm saying the gradient of this line SQ is the same as the gradient of this entire line, which is SQ, right? We found the gradient of S2 to be 2 over there. Why are we saying this they are equal? Because SQ and N are collinear. What does it mean to be collinear? Which means all these 3 points, these 2 that I mentioned there, they are on the same line. They all fall on the same line. So if they fall on the same line, which is the gradient between any of those 2 points will be the same. Which is the gradient between these two, the gradient between any 2 of those points, it will all come out the same. So the gradient of SQ, which is the gradient of this line, is the same as the gradient of the entire line, because all of those points are collinear. No problem. Now, we're told that LQ is perpendicular to QS. That's what we're told in the statement, right? So if 2 gradients are perpendicular, this is what we know about Euclidean geometry, about analytical geometry. The gradient of your SQ times the gradient of your LQ is equal to minus 1. You get this condition if the 2 lines in question are perpendicular, and you're given that your LQ is perpendicular to what? It's perpendicular to SQ. That is why we know that the product of the 2 gradients will give us a minus 1. So the gradient of SQ is 2 times the gradient of LQ, which is what we're interested in, because we want to find the equation of this line. So we need to know this gradient. So this is equal to minus 1. So your 2m LQ is equal to minus 1 divided by 2 divided by 2. You get that your gradient of LQ is equal to minus 1 over 2. So here's the gradient of your line LQ. But we want the equation of the line, right? So we have the gradient to be minus 1 over 2. So we want the equation of the line. So y is equal to minus 1 over 2 x plus c. So we only need to find the value of c. How are we going to find the value of c? We need at least 1 point on the line LQ. On the line LQ, we need 1 coordinate, or 1 point. So we have a point Q, which have coordinates 4 and minus 8. So we're going to use this to find the value of angle C, because this is x, which is this part, and y, which is that part. And then we're going to find C. So in that case, the coordinates of Q is 4 and minus 8. So we're going to say y, which is and we have y is equal to minus half of x plus c. Our y is equal to minus 8 is equal to minus half of x, which is 4, plus c. So minus 8 is equal to minus 2 plus c. So your c is equal to minus 6 if you solve for it. So the line for LQ is y is equal to minus half of x minus 6, which is what they wanted us to show from in the first place. So here's our equation. We're done with this. So now we're going to go to 3.4. At 3.4, they're saying determine the equation of a circle having O, or. At 3.4, they're saying determine the equation of a circle having center at O, the origin, also passing through S. So they want us to find the equation of a circle that is centered at the origin, passing through point S. So this is 3.4. The equation of a circle is in the form x minus a all squared, y minus b all squared, equal to the square of the radius of that circle, where your a and b are coordinates of the center, which is 0 and 0 in this case. So what we're going to do, we're going to say, okay, we need to find, we're going to substitute the coordinates of the center there. So we're going to have x minus 0 all squared plus y minus 0 all squared is equal to r all squared. So we need to find the value of r. So to find the value of r, we need to use the coordinates of s, because this circle of ours passes through point s. The coordinates of s is 0 and minus 16, right? So we're going to say substitute these points here and there, the x and the y, which is 0 and minus 16, so that we get the square of the radius. So we have 0 minus 0 all squared plus y, which is 0 in this case, it's minus 16. Minus 16 minus 0 all squared, equal to the square of the radius. So the square of the radius is equal to 256. Therefore, the equation of a circle is x minus 0 all squared, y minus 0 all squared is equal to 256. So this is the equation of your circle, right? That will be your equation of your circle. And we are done with 3.4, and we need more space, so I'm going to clean the board, and then we're going to do continue with these questions. So what I'm going to do first, I'm going to take all this information and edit it here, right, so that we know what we have and what we do not have. So in this case, the coordinates, we did put the coordinates here, they are, what else? The gradient of ns is 2, there it is, and then the equation of the line LQ, here's LQ. So the equation of this line LQ is what? The equation of this line is y is equal to minus half of x minus 6, right? What else do we have? We have the equation of the circle. Maybe I can write it here. We have x squared plus y squared is equal to 256, in case we need it. So let's clean the board, and then we do 3.5. Okay, so now we're doing 3.5. So in 3.5, they are saying calculate the coordinates of t. So they want us to calculate the coordinates of t. So where is t? T is over there, right? So they want us to find the coordinates of t. How are we going to find the coordinates of t? So what we can do is, look here. This is point P. T is the y-intercept. P is same as P. P is the y-intercept for LQ, and T is the y-intercept for RM. So look, let's say we wanted the coordinates of P, right? If we wanted the coordinates of P, we know P lie on the y-axis, and along this vertical line of the y-axis, x is 0. So on the equation of LQ, we're going to say, okay, here's what we would say. We say, okay, y is equal to minus half of 0, because at that point P, we know x is 0, because it's the same as that one over there, right? So in that case, minus 6. So our y value will come out to be minus 6. So which is the coordinates of P is 0 and minus 6. So if you want the coordinates of T, you're going to use the same method or similar method. So which means what you need to find first, you need to find the equation of this line RM, Once you find the equation of the Rm, you will be in a similar step as this one. You do the same thing. So in that case, we're going to say, okay, we want the equation of Rm. First, in order to find the equation of Rm, we need to know the gradient of Rm. So the gradient of Rm is the same as that of LQ, which is equal to minus half. Why? It's because these two lines are parallel, which is they have the same orientation. Therefore, they will have the same slope. So which means because your Rm is parallel to LQ, that's why they are the same. So if you want the equation of Rm now, say y is equal to minus half of x plus c. So what we're needing, we need to find the value of c. And in order to find the value of c, you need at least one point on that line, and you have that point to be m. So the m have coordinates 6 and minus 4. So we use these coordinates to find the value of c. So your minus 4 is equal to minus 1 over 2 of x plus c. So your minus 4 is equal to minus 3 plus c. Therefore, your c is equal to minus 1. So what you're having now, you have the equation of Rm to be y is equal to minus half of x minus 1. So in this case, you have the equation of this line now. The equation of this line is what? Is y is equal to minus half of x minus 1. So if you want to find the coordinates of t, you know along this line x is 0, substitute 0 there so that you can find the corresponding y value. So in that case, we'll say, okay, y is equal to minus half of 0 minus 1. So your answer comes out to be minus 1. So the coordinates of t is 0 and minus 1. These are the coordinates of t. These are the coordinates of t. So 0 and minus 1. Those are the coordinates of t. That is what they wanted. So we move to 3.6. They are saying determine the ratio of LS to RS. So they want us at 3.6. At 3.6, they are saying determine the ratio LS to RS. This is what they wanted to find. Where is LS? LS is this part over here. It's this part over here. You want LS to what? To RS, which is to the entire thing. So they want this part to the entire length over here. So this is the ratio that they want. They want LS to RS. No problem. How are we going to go about this? So in order to be able to do this with ease, to make it a bit easier, you need to understand the proportionality theorem, right? You need to understand the proportionality theorem. I'll just summarize it a bit. I'll just remind you, because I don't have lessons yet for proportionality theorem, but they are coming up very shortly. So the proportionality theorem says, if you have a triangle like this, right? So let's call it A, B, C, ABC. And this triangle is divided by a line segment. Let's call this line segment DE, that is parallel to this side. Then this DE divides the two sides proportionally, which is it divides them at equal ratios. So in that case, your AD means your AD over your BD is equal to your AE over your EC. Now the question becomes, is this the only ratio that is valid? No, it's not the only ratio that is valid. As long as you take the ratio of the same parts, it's going to be okay. For example, we can say AD of over the entire side. We can say AD over so AD, the small part of the entire side, AB, it should be the same as AE, because you see I said the upper part over the entire side. So it should be the upper part here as well, which is your AE over AC, which is the entire part. This is how it goes. So when you have this condition, as long as you take the ratio of the same parts, that will always work. You'll always be okay. Right? No problem. So, in this case, they want the ratio of LS to RS, which means they want the ratio of LS, this ratio, to the entire side. Look, this triangle is similar to that one, but this one is just upside down. Because you can see that you have the triangle SRM, this big triangle there, right? And this big triangle of yours is divided by LQ, that is parallel to RM. So it's the same situation as that one. Therefore, this LQ divides these sides at equal proportions. That's what you need to understand. So, how do we go about this? We're going to say, okay, we want LS over RS. So we can look at the bigger triangle, which is SRM, which is here is SRM, which means if you look there, you'll say LS over RS is equal to QS over MS, right? Or you can look at this triangle over here, which is this triangle over here, which is SRT, which is you can look at this triangle over here and say, okay, this part here corresponds to this red part, and this blue part corresponds to the entire side. The reason I'm using this one is because it's easy to find these distances here, over here. The distance, this distance, these are vertical distances. So this distance over here, this distance over there, or that distance, it will be easier to find. That's why I'm using this one. You could use this as well, but you'd have to go and calculate these distances, which I'm lazy to do. I don't want to go and find those distances. So I'm going to look at triangle SRT, which is this triangle, and this small triangle SLP. Because I'll say now LS over RS is equal to PS over TS. Right? If I was looking at the bigger triangle, it was going to be LS over RS is equal to QS over MN. But now I don't want to go and calculate this distance and this distance, but it will come out the same. It doesn't matter which one you do. So in this case, I'll say in these two triangles, in triangle SLQ, in triangle SLQ, right, which is SLQ, and triangle SRM. You can say that your LS over your RS, which is what they want you to find, RS. So your LS over RS, LS corresponds to QS, and the entire side RS corresponds to TS. This is what we call the proportionality theorem. We're applying it. Why? Because your LQ is parallel to RM. That's why it works. Right? No problem. So we want LS over RS. So we can find distance QS and distance TS. What is QS? QS, what did I get Q? Should be PS, not QS. Should be this distance over here, PS over TS, not QS. It's PS. It's PS over TS. So what is PS? PS is this distance over here, which is the distance from minus 16 to there. So it's a vertical distance. You know, if you want to find the vertical distance, it's a big Y value minus the small y value. So our vertical distance, PS, is equal to the big Y value. The big Y value is minus 6 minus the small y value, which is minus 16. So the answer to this is 10. So the vertical distance, TS, because it's also vertical distance along that line. The vertical distance, TS, or you can use the distance formula, is equal to the big Y value, which is minus 1, minus the small y value, which is minus 16. So the answer will come out to be 15. So if you want, you said your LS over your RS equals the distance PS, which is 10 over, that's the distance 15, which should come out to be 2 over 3. So that's the ratio of LS to RS, which they asked us to do. So we're done with it. So I'm going to clean that part and we're going to do 3.7. So what are they saying in 3.7? In 3.7, they are saying determine the area of PTMQ. So they want the area of PTMQ. What is this? This is a trapezium if you look at it, because two opposite sides are parallel. Only two opposite sides are parallel, so these ones are not. So this is a trapezium. So maybe you know the area of a trapezium. So the area of a trapezium is equal to half of your base length plus your top length times the perpendicular height. So in this case, it will be half. What is your base length? Maybe, let's say our base length is PQ plus our top length, which is TM, right? Times the perpendicular height. What is our perpendicular height? Our perpendicular height is this one over here, because this is 90 degrees. So it's going to be MQ. So if you find these lengths and substitute them here, it will give you the area of a trapezium. Or another way we can go about it, we can calculate what? How many marks is this thing? This thing is 4 marks. Or we can calculate the area have a look. So want the area of this part over here. So we can calculate the area of the entire triangle, right? This big triangle, and then subtract it with the area of the smaller triangle. So another way you can say our area of what? Of PTMQ. Call it the area of triangle STM minus the area of triangle SPQ should come out. So if you calculate if you calculate the area of this STM of this big triangle, out of this big triangle, subtract this small area, you will be left with that part. So that should work as well. So I'm going to take, so in this case, if I were to write a formula for it, I'll say half base. What is our base? Our base is MS times the perpendicular height. Our perpendicular height over there is MT minus half. Half of what? Of SQ times the perpendicular height, which is QP. So this one should also work as well. This should work as well, right? No problem. So I'm going to use this shorter formula here. So with this one, you can do it yourself as a practice. I'm sure if you say half of MS times MT and you subtract half of QS or SQ times PQ, you should get the same answer as that one. I hope. So in this case, now we need to find the length PQ. What is the length of PQ? The distance of PQ is equal to what? Where is PQ? PQ is this length, PQ, this length over here. Right, this length over here. So it's going to be You know how to find the distance, so it's going to length of PQ is going to be 0 minus 4 all squared plus minus 6 minus 8 all squared. So the length of PQ is equal to an answer to this. So let's punch it and see what we get. The answer comes out to be 2 root 5, right? The answer for PQ. So here's PQ, came out to be 2 root 5. Now let's calculate that length over there. TM, the distance TM is going to be equal to what? Which is 0 minus 6 all squared plus minus 1 minus negative 4 all squared. So the distance for TM is equal to an answer to this. So it's going to be 0 minus 6 all squared plus minus 1 minus negative 4 all squared, which is, this is 3 square root of 5. So the answer, this one was 2 root 5, this one is 3 square root of 5. Then we need this length MQ. The distance MQ is equal to we're going to have 6 minus 4 all squared plus negative 4 minus negative 8 all squared. Let's find the answer to that. Going to be 6 minus 4 all squared plus negative 4 minus negative 8 all squared. This is 2 root 5. So which is this length over here is 2 root 5. So let's use our formula here. So it's going to be half of PQ. What is PQ? Our PQ is equal to 2 root 5 plus TM, which is 3 root 5 times MQ, which is also 2 root 5. So the answer to this, we get that our area of the trapezium is going to be an answer to that. So 0.5 times 5 root 5 all times 2 root 5. What is the answer? The answer came out to be 25. So the area answer to this is that one over there. So the answer came out to be 25, and I believe we are done with this question. And I hope it does make sense to you as it does to me. So we're going to move on to question 4, which is analytical geometry involving circles. So let's go.